Alright, what's up guys? In this video we're going to pick up some more calculus here, and we're going to be back on our basic integration for calculus 1. This is going to be example number 2. So we're asked to evaluate the integral, and we have the 6th root of x squared plus the 4th root of x to the 9th dx. That's what we're asked to integrate here. So again, there is no particular integration technique that needs to be used for this. All we have to do is use a little bit of algebra to rewrite things, and we can make it simpler. So remember, if I have the nth root of, let's say, x raised to the m, well, recall from algebra that that's just going to be x raised to the m divided by n. Okay, so what we're going to do is we're going to rewrite the 6th root of x squared and the 4th root of x to the 9th, and we can essentially turn them into x raised to whatever power and use the power rule for them. So let's just quickly rewrite those, and then we'll set up the integral again. So the 6th root of x squared, we can just simply rewrite that as x raised to the 2 over 6, which we know 2 over 6 can basically reduce down to 1/3. So we can write it as x raised to the 1/3. Similarly, if we wanted to deal with the 4th root of x to the 9th, well, that's just going to be x raised to the 9 over 4. And we can't do anything with 9 over 4. We can't reduce that in any way, so we leave it alone. So now the integral becomes x raised to the positive 1/3 plus x raised to the 9 over 4. And now we integrate it with respect to x. So maybe when you first saw that this 6th root of x squared and that 4th root of x to the 9th, as a first semester calc student, you're probably like, oh my god, I don't know what to do there. But again, we just use some algebra to rewrite it, and so now hopefully you see that you can just simply apply the power rule now and take care of it from there. So I'll do it in small incremental steps. So we got x raised to the 1/3 dx. We'll apply the power rule, and the power rule says we'll have x to the 1/3. We'll add 1 to that, and then we'll divide by 1/3 plus 1. Remember, 1/3 plus 1, that's 4 over 3. So this would be x raised to the 4 over 3, all divided by 4 over 3. And we know we can simply write that as 3 over 4, x raised to the 4 over 3. So that would be the antiderivative for x to the 1/3, and then we'll do the next one, which is x raised to the 9 over 4. Again, we're going to apply the power rule here. So this would be x raised to the 9 over 4 plus 1, all over 9 over 4 plus 1. Let me see what we get. 9 over 4 plus 1, I believe that's 13 over 4, but I'm going to check just to make sure. I believe I'm right, but let me get my calculator just to make sure. And this is definitely something that you need to be doing, by the way. If you got to think about whether or not it's right, you should probably check. So I'll go ahead and check. Yeah, 13 over 4, I thought it was right. All right, so it's going to be x raised to the 13 over 4, all divided by 13 over 4. And we know that we can just simply write that as 4 over 13, x raised to the positive 13 over 4. So that would essentially be the antiderivative for x raised to the 9 over 4. So all we have to do for our final answer here is just combine what we got. So our final answer for the integral, the 6th root of x squared plus the 4th root of x to the 9th. And our final answer for this is simply going to be 3 over 4, x raised to the 4 over 3. And we'll simply add that to 4 over 13, x raised to the positive 13 over 4. And this is an indefinite integral, so we do need to add the constant of integration here. And that would be your solution. All right, so hopefully that one made sense. Again, I will continue to add content to the, or we'll continue to do videos for the Calculus 1 basic integration. But so far I've got 2 examples done, and so hopefully they all made sense. All right, I'll see you guys next time. Y'all take care.